Yeah. So we are good to go. I think people are joining in. Let's wait for them to join. Until then, we'll just play a quick ad. All right, folks, I think we are good to go and start this session. Hello, good morning, good evening, and good afternoon, everyone, from wherever you are joining in. This is Prithviraj. I work as a technical community manager at Harness, and I'm one of the co organizers for Chaos Carnival 2023. It's been an exciting time, and we have had an amazing keynote and the first session of this event by Karthik. And today we are having another amazing session given by Anaïs Urlichs, who's also a developer advocate at Aqua Security, and she's been contributing to open source projects. And while she's not advocating, she also runs an amazing YouTube channel. So, without any further ado, I would like her to take the stage from here. She's talking about stranger danger, how to proactively identify misconfiguration to minimize system failure. Anais, the stage is all yours.
Amazing. Thank you so much. Let me just quickly share my screen. Awesome. Yeah, so this is my presentation. Thank you, everybody, for joining. Thank you so much for having me speak here at this amazing conference. About, I think, 2 years ago, I wouldn't have thought of me speaking at a chaos engineering related conference, but here I am, which is really exciting. So, how did this talk come about? I first want to give you a bit of a background story. I'm actually writing my bachelor thesis right now, and as part of the research on the topic I want to write the thesis on, I came across chaos engineering, and I haven't really looked at that point into chaos engineering. But I thought that would be a really interesting topic, and bringing chaos engineering as well as my work related to Aqua Security at Aqua Security together, this talk came about, Stranger Danger, how to proactively identify misconfigurations. And it's very much related to how we can apply chaos engineering principles onto security practices to make our infrastructure or services more secure. A bit more about myself. Like mentioned, I work for Aqua Security as their open source developer advocate. I came from the open source blockchain space a few years ago into the cloud native space. I have a YouTube channel where I share my learnings on an ongoing basis. And I used to be a CNCF ambassador, but they are rolling out the program. So I'm not a CNCF ambassador right now. I used to also work as site reliability engineer before joining Aqua Security. So a lot of my takeaways, a lot of my learnings are from the SAE perspective, which really helps when looking at chaos engineering. Now, Aqua Security has two main open source projects. Just quickly covering those, which is the first one is Trivy, an all-in-one cloud-native security scanner. It basically allows you to scan all of your resources across your software supply chain for security issues such as vulnerabilities and misconfigurations. I'm going to use Trivy as an example for security scanning throughout my talk. That's why I'm mentioning Trivy right now at the beginning. Our other major project is Tracy, a runtime security and forensic tool using eBPF. Now, you can find both projects completely open source on our GitHub organization. They don't require any signups. You don't send us any data. They are highly disconnected from the enterprise products. So do check them out. But that's that on our open source projects. Now, last year, I was talking a lot about how you can get started with security scanning throughout your software supply chain, throughout your software development lifecycle. I was talking about different steps on getting started, who can get started from different disciplines, such as how do you get started with security scanning, cloud native security from an SRE perspective, how do you integrate security scanning into different disciplines, such as platform engineering, and so on. So these are just some of the talks I gave last year. So they were highly related on the different types of security scannings we can do and who can do them, how to perform them. Now, quick recap to everybody who's new to to security scanning. How does security scanning work? Basically, in the case, for example, of misconfigurations, you have different organizations that define what are best practices. For example, for your Kubernetes cluster, what are best practices for defining Kubernetes YAML manifest? So you have, for example, the Center for Internet Security that's defining CIS benchmarks with different experts in the cloud native space that basically define what are the best practices for your Kubernetes YAML configurations. Then security scanners such as Trivy take those best practices and take your configuration file. For example, this specification is from a deployment, and compare what you have defined in your YAML manifest with the best practices. And then it goes basically through a check mark, like, do you use the latest tag, or are you specifying within your container image a specific version, a specific tag? And then here in this case, a specific tag is defined, so that's a check mark. Versus if you use the latest tag, that would be a fail for that check. And this is pretty much how a security scanner works. It takes information from different sources and then compares your resources to those specifications. For example, if you do vulnerability scanning, Trivy takes from various databases on known CVEs, known vulnerabilities. It takes information, and then if you scan a container image, it compares the libraries and frameworks and tools and so on used within that container image with its database of known vulnerabilities. If it finds any of the libraries and resources you're using within the container image is connected with a library or is one of the libraries that has a vulnerability within it, it will flag that and will tell you about the vulnerability. This is how vulnerability security scanning works overall. So you can use it across your development lifecycle for different resources at different stages. You can automate it through CI/CD tools, and you can integrate continuous security scanning, for example, inside of your Kubernetes cluster of your running workloads. So once you have all of that in place, that's already great. The thing is that within security scanning, so you have different misconfigurations, and we will focus on misconfiguration scanning. Here's just an example of misconfiguration of different misconfigurations and why misconfigurations are so important to look at. So this data is taken from this resource from 2021 Cloud Misconfigurations, and it has basically, this file has a huge list of different misconfigurations, for example, of your different Amazon services, of your Amazon-defined resources that exposed customer or user data in various formats. And the companies didn't know that it was exposing, that they were unknowingly exposing user data. So misconfigurations are basically everywhere, and that's why this talk will focus on misconfigurations. The thing is, even if we do misconfiguration scanning at each of the stages of our Kubernetes manifest, of our Docker file, and we make sure that everything is configured correctly, there's still a high probability that there will be eventually misconfigurations in our resources. Because the thing is, with misconfigurations, the way that we approach them is that we change a resource or we define a resource, and then we scan that resource for any misconfiguration issues. So anything that's wrongly configured. The problem is when an issue is identified, so a critical issue is identified that is not a result of us changing something. We only have the security scan, and then we have to find the issue and fix it. And within misconfiguration scanning, that's really the only time that it's that way around, that only in critical situation we are first presented with the security scan, and then we have to go and find the related fixes. Versus with vulnerability scanning, you usually have the CVE of one of the libraries, and then you have to identify within your resources how to remove that vulnerability from your resources. So within misconfiguration scanning, it's very much the other way around. And in order to know that our processes to identify misconfiguration and fixing them are working properly, we have to actually learn to test, verify, and practice these processes and be able to respond to misconfiguration issues that are identified from our scanners. So how can we ensure that our processes are working as expected, specifically post-deployment? We can take a lot from chaos engineering and apply that to our security scanning, to our security-related tools and security-related processes. So just a quick recap, chaos engineering is a discipline of experimenting on a system in order to build confidence in the system's capabilities to withstand turbulent conditions in production. Chaos engineering overall is pretty much focused on how can we make our services more resilient to failure. It's pretty much focused on, from a security perspective, how can we manage high loads or unexpected loads on our services, for example, as part of distributed denial of service attacks. That's related to security, but it's always very much focused on how can we optimize the response to failure of our services and withstand those conditions. So here are some of the projects that are open source and related to chaos engineering. I've looked at several of those and looked also into ways on how we can adopt them on to a security perspective. In the case of there are actually some ways in which you can write parts of their programs to apply to misconfiguration issues, to test misconfiguration issues. But I will talk about it a bit later in the presentation. So through applying chaos engineering onto security, we arrive at security chaos engineering, which is kind of a separate term. But the thing is, security and chaos, the two words don't go very well together. People don't really like to bring chaos into their security practices and processes. It kind of makes people have uneasy emotions and freak out. So you can also use as a term security experimentation. That's a little bit more positive. What is security chaos engineering actually? So this is a definition that's taken from a report published in 2020 on security chaos engineering by Aaron Reinhardt and Kelly Shortridge. I don't know how to pronounce her name properly, so apologies for that. And security chaos engineering is basically the identification of security control failures through proactive experimentation to build confidence in the system's ability to defend against malicious conditions in production. So similar to chaos engineering itself, we want to proactively test that our tools, our processes are working as expected to build higher confidence in those tools, in those processes. But in this case, in the case of security chaos engineering, it's very much to test how do our processes, our mechanisms, whether those are tool-based mechanisms that are automated or human and process-based mechanisms, how do they respond to any malicious conditions that are identified of our running workloads in that case. So here are some more principles of security chaos engineering. We want to seek proactive and adaptive learning over reactive patching. What happens in the security field, whether you're just getting started with security or also if you're already having established processes, a lot of times we are reacting to the issues that we are seeing, right? So for example, you see vulnerabilities and you fix them, right? You are hardly ever testing whether or not the processes, for example, the tools that are running within your cluster to identify new vulnerabilities are actually working as expected. You only test them when externally there are new vulnerabilities identified that your tools and your processes and your applications have to respond to. So for example, you have a running application and a new vulnerability related to a library that's in that application is identified. Then the security scanner inside of your cluster that's scanning your application on a continuous basis might identify that new vulnerability and hopefully notify you about that if it's a critical vulnerability, for instance. And that's in that case, you're then reacting to that scan of that identifies the vulnerability and you are fixing it. But it's very much a reactive approach, and we want to turn it into a more proactive approach that we know that those systems that we have in place to identify security issues are actually working. Then we also want to build a learning culture around how organizations build, operate, instrument, and secure their services. We have this kind of learning culture very much in the SRE, in the site reliability engineering space, where we treat our resources, our applications as very dynamic. In the SRE space, we expect resources to change on an ongoing basis. We expect to be alerted of things not working and services not responding. We expect that in the SRE space. We don't expect it necessarily in the security space. In the security space, we don't treat resources in the same way. We don't treat them as dynamic. We treat them more as static, as snapshot in a single point in time. and basically changing them at a single point in time. We don't expect them to be continuously changing. And security chaos engineering is also about creating control tasks where you already know what the issue is going to be, and you're just identifying what the effect is. That the effect is what you expect it to be. So if you have processes in place, you want to trigger these processes, you want to trigger the system to alert you of critical security issues. Now, one project that has been developed related to security chaos engineering is Chaos Slinger. Chaos Slinger is now an archived project. It was focused on creating issues, security issues within your AWS services. And then you could test that you identify those security issues and that you know how to respond to them, and that the other systems you have in place respond to those issues as expected. Now, Chaos Slinger is not actively maintained anymore, like mentioned. However, different projects have forked Chaos Slinger and modified and implemented their own version. But the thing is, security chaos engineering is not talked about as much as, for example, chaos engineering, even though it's not a new term. It's like the earliest presentations I could find on security chaos engineering are in 2017. So it is something that has been around since a long time. It just hasn't really catched up. Now, there is a longer book being published in about a month, by the same authors that wrote this report. So the same two people. And it's a whole book on security chaos engineering. So that's going to be exciting. So some of the key points, if you're doing security experimentation, is similar to chaos engineering. You can adapt a lot of the principles that you hear about from different presentations throughout this conference. You can adapt the same principles onto your security testing, your security experimentation. So when you do a security experiment, you want to define as well the scope, the variables that you're testing. What are you testing? How are you testing it? You want to have it a time-boxed experiment. So it's not going on forever, but you want to have a clear start time and a clear end time. So within that time frame, you can, for example, define, okay, if it's going to be 6 hours, you want, and you're triggering, I guess, a change in misconfiguration. In your configurations, you're triggering a misconfiguration scan. You want, for example, the Trivy operator to pick up that misconfiguration scan. You want then the Prometheus operator to pick up on the new metrics that define that new critical misconfiguration within your services, and you want to be notified about it, and you want to have a clear outcome at the end time. I'm going to talk about the process in a little bit in the next slide. But basically, once you have defined your experiment, you have done your experiment, maybe it failed, maybe the outcome was as expected, but you can then have postmortems that build upon those experimentation, and go into further detail, and you can advance your infrastructure from a security perspective or gain higher confidence in your tooling, in your processes, and the people that are working with those tooling. So I had thought I wanted to prepare a live demo, but what you can maybe hear in my voice, I was a bit sick throughout the past week, so I didn't manage to finish the demo. So I'm just going to talk you through how a security experiment could work and what you're testing for. So if this is your Kubernetes cluster, you have your application namespace with any of your resources related to your application within that namespace. You then have your monitoring namespace where you have all of your monitoring tools. Maybe that's Prometheus, Grafana, maybe other tools that are basically picking up on your metrics, that are alerting you on anything that's unusual maybe within your environments. And then you can also have a security namespace with all of your security tooling. For example, in our case, you can have the Trivy operator running that performs security scans of your resources if anything changes within them. So, for example, if the container image of your application changes, then a new scan is going to be triggered for vulnerability scans in the Trivy operator. If any of the configuration of the YAML manifests that are related to your application change, then the Trivy operator will scan it for misconfigurations in those manifests, in those definitions of your application. So it will perform the scan, and then based on that scan, it will generate metrics. Those metrics can be picked up by Prometheus, forwarded to Grafana, maybe put into pretty dashboards. But if there's anything unusual of those metrics, Prometheus can then alert you that there's something, for example, there's a new critical vulnerability, there's a new critical misconfiguration within your cluster that you should take a look at. Right? So this could be like your setup, and ideally the setup works, and you are alerted of anything new changing within your cluster, any critical issues, and you can respond to them and you can fix them. Now, usually we would test that if something changes within our application that we didn't identify pre-deployment, or if there are if we have something like some long-lasting components of our application that don't change much. For example, sometimes we have, I don't know, we have certain cron jobs or something running within your cluster that just performs something on an ongoing basis that you don't actively update on a regular basis. Now, if new vulnerabilities or misconfigurations identified of those resources, the Trivy operator should pick those up, right? And you should be notified about it and so on. Now, we want to test this process also if there's nothing changing from our part, or if there's nothing changing externally. You don't only want to test this process if there are new vulnerabilities identified externally or new misconfigurations implemented on an unknowingly basis in your cluster, in your workloads. So this is ultimately the process that we want to test. We want to invoke a configuration change of any of our resources. Then ideally a Trivy scan is being triggered of those configuration changes to identify any misconfigurations. Then Prometheus picks up its metrics, sends an alert through Alert Manager, for example, and someone hopefully looks at that alert and then creates a fix. Now, at each point, there's obviously failure can be introduced, can happen, that this process doesn't work as smoothly. And that's something you want to identify through security chaos engineering, through security experimentation, on purposefully triggering any configuration change to make sure that this process works also when you're not triggering it, also when it's invoked from factors that you don't have as much control over, where you don't know the cause for the configuration change. So just a quick recap on as a last thing on what Kubernetes operators are. They are basically codifying human processes. So instead of me accessing the cluster and performing manually a Trivy Kubernetes cluster scan, the operator does it on a continuous basis. And we can also use operators to perform these configuration changes within our cluster. You could either fork a project such as Chaos Slinger, you can adapt through an SDK of an existing chaos engineering project, you can adapt that and use it in such a way that it introduces configuration changes within your cluster, or you can build your own operator to perform configuration changes. There are multiple ways on how you can invoke misconfigurations within your cluster to test that process. You just want to know which tools you want to test, what processes you want to test, and which tools you're using to test those. Now, summarizing just the main benefits of security chaos engineering and why you might want to get started with it, as well as with chaos engineering. So you want to build an effective security response, and if you have a theoretical security response, if you define within your team, if a new critical vulnerability is identified, we do X, Y, and Z, you want to test that X, Y, and Z process to build higher confidence in your system, in your processes, in your people, to have continuous learning within your team on how you can improve the security posture and the security scanning of your resources, and to enhance runbooks. So everybody in your team is ultimately empowered to deal with security issues within your environments. Here's some of the resources I used. So here's the report I mentioned, published in 2020 on security chaos engineering. And here's the book that's going to be published by the same authors this year in a month. And here's the presentation on Chaos Slinger, where they provide more detail on how Chaos Slinger came about and what it's supposed to do. You can, if you have any questions, you can find me on the Slack here during the conference, as well as on the Aqua Security open source Slack. If you have any questions on using Trivy, the Trivy operator, for security chaos engineering, for example. And yeah, I'm also very active on Twitter. You can find me at Urlichs Anaïs if you have any questions after this talk as well, if you don't get to ask your questions through the Q&A now. Thank you. We good?
All right, nice. That was an amazing talk, and we are good. We have got 3 questions as well. Thank you so much.
Amazing.
An amazing talk on security chaos engineering. I'll take the questions quickly. So the first question is by Julio. He asks, What's a typical security chaos engineering workflow look like?
So it's pretty much, I mean, it's a very new kind of process and term, I guess. You can use similar workflows from chaos engineering and security chaos engineering. The thing is, the main difference is what you are testing. So in security chaos engineering, you want to focus on testing anything related to your security posture. For example, misconfiguration changes, or let's say within security chaos engineering, you would want to test, for example, any port changes that could expose your services in a way that you don't want it to. You want to see how your firewalls, for example, respond to those changes. So you would adapt the same workflow of from chaos engineering, but just change the variables of what is being tested and how it's being tested.
All right, thank you so much, Anais. The next question is by Anusha. She asks how to take controlled approach of injecting chaos, given that the process of chaos injection itself needs to be granted higher level of access, etc. Should each chaos type have access of its own, or if combined, how to ensure blast radius is limited?
So you want to make, I hope I understood the question correctly. So you want to make sure you're only testing one thing or like one variable at a time, uh, versus getting started with kind of just randomly introducing security issues in your infrastructure, right? That's kind of defeating the point, because then you might accidentally expose your services or your application to things that you don't have control over. So you want to ensure that if you do security experimentation, you keep control over what has been changed, how has it been changed, and how you can fix it. To really have like you want to have really controlled experiments. And again, that's why security experimentation is probably a better term than security chaos engineering, because you don't want to randomly introduce chaos on an uncontrolled basis inside your workloads, to your workloads.
Thanks a lot, Anais. Next question is by Ariel. She's asking, what do you think about standard adoptions like Open Telemetry for improving these workflows?
I think it's a hand-in-hand process. I talked a lot about that last year, that you ultimately, especially if you're using open source security scanners such as Trivy Operator, it needs to be integrated in any observability-based tooling for you to have access to your security reports, to the information created by your security scanner. So it's very much site reliability engineering, security scanning go really hand in hand, especially when you're using open source tools. I don't know how you would do one without the other, really.
Thanks a lot, Anais. The last question from Javier we'll be taking up. He's asking, which tools did you learn first to gain confidence and later implement?
So I'm just actually getting started with chaos engineering and adapting it to security chaos engineering. So I'm right now writing my own operator, and I was hoping to show a little demo of it here. That's with Cube Builder. So I'm writing that operator with Cube Builder that is making changes to your deployments in your cluster. So you can get started writing your own operator, or you can use any SDK from, for example, Litmus or other projects, to adapt what they provide to the security space.
Thank you so much, Anais. That was quick. I think we can take the last question as well. We have one left. How is Aqua implementing security chaos engineering as of now? What's the next steps looking like in terms of security chaos?
Yeah, that's a great question. So I actually, I'm part of the open source team at Aqua Security, so I'm not familiar with how the enterprise teams are operating and how they would implement security chaos engineering. I gave this presentation to my manager at the open source team, and he told me before the presentation he's very skeptical why that should be a thing, security chaos engineering. He was like, "This can't be a thing." That was kind of his approach, and I was like, "But this has to be a thing, you know?" Like I was so excited about it. So I gave him the presentation, and at the end of the presentation, he was like, "This actually makes sense. Like it makes sense that you don't want to just blindly rely that the Trivy operator will tell you, and your observability tools will tell you about critical issues within your infrastructure. You should test that process to make that, to have the confidence to be ensured that you will know about the security issues, right? That's like the tooling that you use, but also then the human processes. Do people are empowered and have the knowledge to deal with critical issues within your application, within your infrastructure, right? That's all things that you should be testing, and that usually we don't talk like from the security perspective on how can you actually test that, and that's where security experimentation comes in. So at the end of the presentation, he was convinced that it should be a thing. Yeah,
All
I
right,
hope
thank
that
you
answers
so
the
much,
question.
Anais. I hope that answers your question, John. And that was an amazing presentation. And thank you for answering all the questions.
Thank you for
Amazing
having me.
once again,
That
folks.
was
And
great.
stay tuned with following Anais's journey through chaos engineering. You can follow her on Twitter. And we are having a couple of amazing talks next. One by Tarun Khosla from Nagaro. He talks about shift left chaos engineering. And one by Jay Prakash from TCS. He talks about accelerating and adopting chaos engineering. So I hope you had an amazing session, and thank you once again, Anais, for this great talk. Thanks everyone for tuning in.
Amazing. Thank you so much. Bye bye.